We are back today. I want to look at ephemeral storage. I want to start by sharing the results that we had from my previous video and walking you guys through it. There is a lot to go over today, and I'm really excited. This kind of hopefully will conclude. Maybe we'll have another session to just kind of finalize the code for ephemeral storage and looking at the results. Because it honestly takes a while for the download to complete. So we'll see. So let's start. I wanted to start looking by this is the results of running downloads using the AWS CLI. And yeah, basically I had this file that's about 160 gigabytes. So what we're doing here is we're downloading this file to disk. It started at 8 at this time in UTC, and it concluded at 35, which is 35 minus 8. That's about 27. So 27 minutes just to download, and then almost a whole hour just to do the compression using PXE. And to be completely honest, I am not sure if that is a compression problem or a I'm not sure where the problem is. So my analysis of this is because of the network bandwidth. Right now we were limited at about 1 megabyte. If we go back to the EFS metrics, so we can actually open it up here. I think it's interesting. It's important to look at these things. It's important to understand how they work. I'd love to even do a deep dive and just look at some blogs and see what people are saying about EFS. But my experience has not been great in terms of CDK code. I mean, I finally figured it out, and hopefully I can publish a construct so that other people don't have to go through this. But let's just take a look at EFS here. Okay. Yeah, so let's take a look at monitoring. Let's go to CloudWatch. Today I was thinking of switching it up instead of this silence to play some music. So let's see how that works. Just something very light. That's really what I listen to when I'm working alone. Show you guys. Internet bandwidth just starts to be completely slow. While this loads, let's just take a look at some blogs here. So EFS slow. Let's see what people are saying. Yeah, I like to read these things. That is true. That is just my analysis of this. Was that is network file system have inherent trade-offs over local file system. EFS doesn't change. That don't expect the moon benchmarks and monitor them. They'll do fine. So yeah, just reading here, it looks like, I think this blog is probably the right one, but let me, GFS performance WordPress, yeah. For a while, performance never matter, especially with a ton of tweaking. If you tweak your output cache, and possibly something like one mesh. Yeah, I think don't even do no, that's not a problem here. I've used cluster and FSUS. They're all their yeah, so that's true. So unless like for a very specific use case, I'm glad that we have the code. That is very good. So I think I'm gonna commit some of that. Let's see. Let's see how we can commit this. I probably want to commit this in a way. So let's see. Let's take our code here. So what I want to do is I want to obviously battle test this against EFS. Fargate task CDK add. Let's take a look here. Yeah, so let's say we just do, the thing is you kind of know before starting the task. So let's just take a look. Let's just backtrack here. And let's go and take a look. Okay, so yeah, in this case, we can move this to somewhere here. Private mount EFS. And the way we do this is we take both of these. and we do this compressor dot add first to add volume. Just the compressor task, the default container. So the nice thing is that really like so I really didn't need to do anything. So what we want to do is we want to take a look here. Excuse me one moment. Close this. And let's see. So this is the number of ephemeral storage. That's in the task definition. So let's just take a look at the run task API. Let's take a look if Ephemeral. Nice. Yeah, so technically it seems like you can tweak the number when you run it. So I'm actually gonna leave it that way. Yeah, let's just do that. Should be chill. So I am going to remove these. Yeah, I'm just gonna remove them for now. Let me just do that. Let me go to my actually just gonna completely delete them. I'm gonna keep their code though, but I am going to delete the majority of it. Actually, I'll keep it just so it works. I'll keep those just so it works. So yeah, brother. I don't think we need them anyway. So quick EFS, create all this stuff. It's like some nice to have things. I believe we should be able to run an npm run deploy right now. But before that, let's do a couple of things. Let's clean up this here. Let's see. No problem. Let's try this. Let me do a go build. Before that, actually, I did want to say put things in the compress task. So let's do print. Just do go build. Let's do npm run deploy. Wrong thing. Yep, let's move this back to CDK. Let's do npm run deploy. So again, what we're going to be benchmarking right now is I wanna see what it's like to run with local storage. Now, while this deploys, I'm going to open this here. Right. So now let's see what the code looks like to do this. So more than likely, this will be on 6. This is going to use the default subgroup. And then let's take a look at the ephemeral storage. I bet you it's under container overrides. Right. So name, environment files, CPU, resource requirements. Ephemeral storage. Oh, it's in its own thing. Okay. It's still under here, ephemeral storage. I'm gonna give it 200. That actually is a struct, so I'm gonna do size in GB GIB. It's kind of sick. So ephemeral storage, so that's after that list. Container overrides for different containers. Okay, let's validate the latest task. take a look at the task definitions. Told you this would be on revision number 6. Yeah, so let's just try running it and let's see what happens. The one thing that I did want to do is I do want to kind of delete these and see what the performance is. Also pick a different test thing, but just literally took a second. So deleting should not really be a problem. Right? Let's test it. Let's run it. So scripts and then run compressor. Okay. Let's go to ECS. Let's go to our clusters. Nice. Let's take a look. They're both running, which is amazing. Let's take a look at some of their logs. Ooh. Ooh. Well, we won't really know what the fuck happened. Well, I see. You accidentally removed the weight. Right. We accidentally deleted the file that we wanted. So let me just let's clean these up. Clean these up. Let's go to let's go and fetch our All right, so let's see. Let's copy over one of our big ones. This one, I'm gonna actions copy over to Swift tests. Assuming we've been using this one. Oh, it probably got deleted. Probably gonna just rename this to 70. Let's honestly just use test compressor. Let's rename this. So, okay, so we're gonna launch this. Okay, let me do a go build. We validated the upload also has let's do a command here. Cool. Let me do a go build. Yeah, then let's just deploy it. So let me do npm run deploy. So scripts cdk go code. Yep, I had to do this locally before, which is totally fine. It's just AWS S3 CP S3 : with then there be /test/final. Swift test v1, and then let's send it to test compressor final underscore 2022 0609.csv. I'll do dash profile Swift. Yeah, so this is the copying rate on S3 servers. It is insanely quick. I also just want to show you what it's like to write the the bash program. I'm gonna assume we have a compressor.sh that we can run. Interesting. So in the container overrides Docker image. Yeah, so you can actually specify a command, it seems like, in the run task. So there's a command that you can give. Interesting. Which I think is really cool. Yeah, let's assume that there is this. Yeah, if you write a shell script, let's assume you echo rec, right? And let's say this is RHA modded compressor.sh. Let's say you do compressor. It does nothing, but if you do rec is equal to 123, you get 123. That might be a vibe, as you pass the request that way. So let's say you do AWS S3 CP, and then you do S3 : And the nice thing is you can actually do concatenation. Let's do source bucket, source key. No, you actually want to do local, so let's just say you do /data / you can install a UUID. That's true. Every single one of those is going to be different, so you don't even need this really. And I'm pretty sure base name Linux Yeah, if I do base name of, let's just say, random folder or just folder file .yz. Nice. So say dollar base name that is amazing. So then shell script get ID, but we don't really need to, right? Because yeah, you can just do download it like just right here, right? You don't really need to do this. Then you can do pigz. Do the same thing here again. Definitely do -f. AWS S3 CP tst .gz. This is literally all what this shell script we need. And that's literally all. Like, it is pretty crazy how little code you need. You don't have retries, you don't have nothing. But that's okay. The beauty of how simple this is, I think, says something. So anyway, we're gonna get back to that. This got uploaded, so now I should be able to see it here. Run compressor now is targeting the same path. Yep, let's now I am still not sure why this keeps on happening, but that's okay. That is wild. Should be able to go here and take a look at some tasks. We have a task running. It's running revision 7. Started that download, which is great. It's gonna take a while. Likely is fine. Likely it's fine. I mean, if it didn't complain about it, then it should be okay. It's gonna take a while, so I might have to pause the stream or start a new one for this instance. But yeah, maybe while I have you, maybe we can take a look at this script. How simple it is. Could be super interesting just seeing it work in action. Let's see. Can I echo the following? That obviously didn't work. Let's do $source. Let's see, base name. Yeah, it shouldn't need it. Yep, so we can just comment these for now. So we can take this. Let's do echo notepad. So let's see. Kind of need to get it closer. I don't think there's a concept of spaces. Missing operand. That's okay. Let's pass the source key. Nice. So that worked. Okay. So now let's say echo using the following path. For downloads. Starting Linux echo with timestamp. see. Yep, no, it's the same. So you're gonna need to yeah, so you can actually have a function just called log. My guess is that this needs to be at the top. Nice. Source key. Node path. Completed. Source key locally. Then here you start running the compression locally as well. So now what we need to do is we need to do this $download path.gz. Let's do another log. So this is the shell script that we basically need. It is pretty cool. This obviously is not going to work. Let's take a look here. It started 14 minutes ago. Keep in mind their download of the other one that was over the network took about 27. So we're about half of the time already. It's hard for me to see the performance. I kind of would need to pipe the output. But yeah, let's maybe keep this in our back pocket. Set dash G dash E. Remote path. You probably want to call it URI. Source remote URI. DST remote DST key DST bucket DST bucket DST key initializing the script. Remote URI. And then you want to compress the down path. So that's really cool. So we're taking a local file. It's a very cool script. Nice, like you said, it's just a script. Okay, I'm gonna pause the stream, or I will actually just stop it right now. And if anything, I'm gonna resume and create a new stream. If you guys are interested, let me know in the comments. I haven't really been getting viewers, so I'm kind of just doing this for myself. But if you do find this interesting, just add something to the comments, and I'll create a new video. And yeah, thank you for tuning in.